The topic is inheritance in Python. So Python, so inheritance here is the ability of one class to inherit the characteristics, the attributes of another class. So the class from where the attributes are getting inherited is called the base class, and the class that is deriving the characteristics is known as the derived class. So it's nothing but it helps to ensure reusability. It helps also to ensure that all the classes which are originating from one base class have that similar set of characteristics. So it's basically to ensure compliance and also for reusability of the code. Inheritance can be single inheritance. Single inheritance means there is one parent class and one derived class. Multi-level inheritance, there is one base class, derived class, and then in turn there is another derived class. That can be multi-level. Hierarchical means there are more than one derived class. So one parent class having many derived classes in a hierarchical nature, that is hierarchical inheritance. And then there is multiple inheritance, that is multiple inheritance as in many base classes. Always remember, multiple inheritance refers to many base classes, and then many base classes making use getting used for one derived class. So consider here, if there is one class which is vehicle. So here I have declared a class variable, and then there is wheels, engines and seats, which are the instance variables. Now the class car inherits vehicle, which is specified here, and there is nothing specified over here. When I say C1 equal to car of, car does not have its own initialization method. It uses the initialization method of vehicle, which expects 3 arguments, and so this line will give an error. So here, if it does not have its own initialization method, I call this. Car can have its own initialization method also, and then I will pass its own parameters, and then vehicle's initialization method will not be called, as it can be seen over here. Now when here I'm calling the display method. Now display method is defined in vehicle, and vehicle is referring to wheels, engines and seats. So that time it is giving me an error. So here the need is that we should explicitly call parents init and specify all the attributes. So here I say vehicle dot init. So here I'm calling that method, passing self 4 comma petrol. These are some static values. These are some constant values which are passing. And now when I call this display car, it will call car type as sedan and this manual drive type. In display it is going to call 4 petrol and 5, because it was already initialized using vehicle. So dunder dict method on C1 will show, one second, I have not displayed. One dunder dict on C1 will then have 5 attributes, as can be seen here. 2 from its own class and 3 from the vehicle class. So this is the class vehicle and here is the class car. I'm calling the initialization of both, initialization of vehicle, initialization of car here. Now let us learn about super. Super actually refers to the base class. It refers to the immediate parent class. So here, instead of referring to vehicle, I can call super, but in one another changes in super I will not pass self also. So super dot init, so it will call the vehicles init method. I need not pass that self argument also here. uh, it's just does the same thing but called with the super keyword, and I need not specify the argument self here as we did in the case here. Here the default arguments are getting passed, and here super method is being used. I can call the instance method of the parent class, this is disp. It can be called using vehicle dot disp self, or otherwise I can say super open close bracket dot disp open close bracket. That is also another way that will do the same thing. Or I can also call it self dot display method. This will also give me the same result as seen. So these are the three ways in which I can refer to the parent class instance method. Consider if we have multiple inheritance, that is many base classes. So here I am also including a color, vehicle, and car is inheriting both color, vehicle and color, and the order in which that is also is very important. I'm also calling the initialization of both, where I say vehicle dot dunder init self comma wheels comma engine and seats, and for color self comma red. This is the value that I'm passing here. So when I call this, it will be first init of vehicle, init of color, then init of car is being used here. Then when display car is called, it will be display of vehicle, display of color, and then whatever are the lines of code left in the display car function. So super by default refers to the first parent class. So in this case, if I call, see there is vehicle, and let's say if I say super, then it is referring to the first base class. If I want to refer to color using using super keyword, then I say super of vehicle comma self. This is referring to the color class. Again the same output, but just that different way of referring to it. Instead of calling it color, here I am referring to it using the super keyword like super vehicle comma self. Now let us see one example for multi-level inheritance. There is company, department is inheriting from company class, employee is inheriting from the department class, and here when I call the print, it displays everything. So one simple example for multi-level inheritance. Let us look at this method resolution order. Method resolution order, for in cases that we have multi-level inheritance, method resolution order becomes very important. So first it is the class, then its parent, immediate parent, then the parent's parent, and if there is any other object that is there. So if we see dunder MRO on the employee class, it shows that first it is the employee, then it is the department, then it is the company which is looked for the method. Like for example, if there is one method, it will search for the method list in employee, then it will search for the methods in the department. If it does not find that also, it will look for company, and then it will look for any other, if there is any built-in method, it will look for that. So consider if I have class A, class B, and class C is deriving from A and B. So in this case, object 1 dot A. So now it is getting A from both. It is getting from capital A also. It's getting the A variable from this class also and from this class also. So in this case, the order becomes very important, where this or A will take precedence. If I try to display C dot Dunder MRO. It shows C, it is then A, and then it is B. Now C is not having its own A variable. So it will look for capital A, this class A. And then it finds it and so it displays it. Vice versa, if it is B comma A, then 200 will be taken. Consider here if I have A and B both being used in C, D which is derived from B, and then E is derived from C and D. So now if I look for the MRO of E, it is E and then C. Now C is making use of both A and B. A is good, but B is being used elsewhere also. So it will be C, then A, and then it will look for D, and then D's base class which is B. And then if there is any other object, it will be included.